Hello, I'm Henry from Excellent Analytics. This tutorial video will let us explore and better understand the DAX function of all selected, and all except in Excel format with an example, as shown here in Table 1, which is a common format of raw data in real world, but a simplified version in tabulated format by monthly, location, product, and data, such as in sales. Remembering this all function by heart is important, as this will make easy to write a DAX language in succeeding real-world application that I will demonstrate in the future. So let's carry on. I already combined all three functions into one pivot table derived from the above table 1. To see how they differ each other by seeing them side by side, I assume that you already know how to create a pivot table and add measure to create a DAX formula similar inside these pivot table fields. Nonetheless, I still added some quick tutorial on how to create a pivot table from the scratch later in this video, so just hang on. So each function were color coded. Orange is for all function, color blue is for all selected, and green is for all except. This is to minimize confusion and easily to differentiate each other when any of the filters above in this slicer is activated. So let's deactivate them by clearing all the slicer. It is advisable to make your own sample of pivot table such as this, so that you may be able to simulate what all function can do when you are making a complex calculation in the future. This way you can revisit anytime you want in case you forgot how this all function behaves. As you notice that I created a long name in this field because of added close parentheses. This is just a guide only that we override specific column in month, year, state, and product within the parameters of all and all selected function. So let's begin in total sales or sum of sales. This total sales is calculated in this manner. So this is the simple syntax, sum, same as in Excel function, and the table location and the column name, which is the sale. Check the formula and click OK. This total sales is similar to the built-in or ready-made calculation of pivot table such as this. When you drag and drop the sales into the values, I'll put it before the total sales. As you notice, the result is the same. To simplify the matters, we just focus on total sales created by DAX formula. So let's remove this sum of sales. One of the fundamentals to remember is the purpose of all function is to lock down which columns you want to remain the same in every group of items when sum up, such as this. When filters are cleared or activated. This is essential calculation when you want to fix the value across the group of each item in a pivot table or in a chart or in a matrix, either in Excel or Power BI platform. Please do note that this method is applicable in Power BI as well. For example, when filters are cleared in this slicer, this is the default result of all selected, and all except. Let's observe and find the cells with a common result And let's review the DAX formula each column. So let's begin in this sales all table. As you notice, the result is the same as the grand total. So this all table is written in this manner. The syntax is calculate, expression is the total sales, and the first filter applied here is all with the table location only without a column name. Check DAX formula, click OK. The second one is sales regardless by filtered product. This column here is calculated in this manner. Oh, sorry, this should be the one. The syntax is all, table location, and the product column name. When we observe this carefully, you're going to notice that if I highlight the Florida, each product across the product has the same result, 35, 35. Same as in Nevada State, same as in Texas. You will see this clearly when I swap the product and state and highlight the Florida State, all 35, all 15, Nevada, all 18. This is actually calculated in this manner. All the sum of the Florida loan, regardless of this product, is actually 35, same as in Texas, all 18. Of course, Ohio State and California, Arizona has only one product. Now let's go to the sales all selected regardless filtered by product. As you notice, they are the same as the previous uh, column. This all selected is expressed in this manner. Same, the expression is total sales, and the first filter is all selected. Location is table 1 and with a column name. Later on, you will see the difference when we are going to activate or make this slicer active. The next one is sales all selected regardless by filtered state and month year. The expression is this time it has two filters. Filter 1, which is the state, all selected. Filter 2, which is the month year, using all selected as well. Check the formula, and there you go. Here is not noticeable already that across all the states, each product, the result is the same, 27, 44, 63. Of course, this is the result of the sum of all sales of product A, which is 27. This one is 44 chapter. Next one is sales all selected table. The expression is same as previous, total sales, and the filter one is all selected, and the location is only table 1. As you notice that this sales all table and sales all selected table has the same result. Later on, you will see the difference when the filter is activated. Lastly, the sales all except by filtered product. This is written in this manner. All except this time the all except is asking two parameters, table 1 and a column name. It has to be at least two parameters. Cannot be only one, which is the table name, unlike the all and all selected. Here it is also noticeable that the result is 2744 across all the state. It is similar in these all selected regardless of filtered state month year. You will see the difference later on when I activate the filter. Let's observe carefully which column or calculation change when I begin to filter the state. Let's observe the sales all table. The result remained the same prior filtering the state. How about the sales all regardless by filtered product? It also remains the same when you observe the Florida, California, and Arizona. How about the sales all selected regardless filtered by product? Also the same as this. How about sales all selected regardless by filtered state and month year? Let's observe this carefully. This change. How about sales all selected table? This also changed because prior the filtering, the result is 134, same as sales all table. Lastly, sales all except by filtered product. It remained the same as 27, 44, 63 across the product and state. So which column that changed is only this sales all selected regardless by filtered state and month year, and also sales all selected table because this we are filtering the state here is included in these parameters, and also here it means all selected table, it means all columns is affected. That's why this also change. Now let's observe carefully when I begin to filter the product alone. So as you notice, this sales all selected regardless filtered by product and sales selected table did change. While this sales all table and this one and this one and the fourth one did not change even though I filtered the product. Now let's take some minor variation by collapsing the state and remove the grand total and start filter the state and observe the result which column change. So this all four column change while this sales all table and sales all except by filtered product didn't change. How about the product? Let's filter it. So this sales all selected regardless filtered by product and sales all selected table change. How about swapping the product and state and collapse the product or hiding it? And let's observe the result when state is in filter. So basically, these three columns change while these sales all regardless to the product and accept didn't change. So now you know how all selected and all accept functions behave in a single and multiple fields. These functions are important when you want to lock the summation of a certain group of items or use it as denominator or in any calculation you want to achieve, such as this in percent calculation. Like basically, this is a percentage of this total sales divided by the sales all table. So if we move forward, same as this, and same this as well. Yeah, you just convert them into a percentage such as like this. Yeah. So the last thing I'm going to show how this pivot table was made. So let's do from the scratch. Let's copy this table and put it somewhere here. Yes. So first step is convert this into table. Yeah, my table has headers. Yeah. Oh, there's one thing that is not converted into month here. Just do like this way. Uh-huh. Then find this month year. Month year. There you are. Then click insert to make a pivot table and add this data to the data model. Click existing worksheet and put it here. There you are. Then drag and drop this product into rows field and state into rows field, sales into values field. Then convert these row labels into show in tabular form, and we just repeat so that the empty cell is filled. Then remove the subtotal. Then create a slicer such as this. Click Analyze, Insert Slicer, check month, year, product, state, then voila. Month, year here, product here, just like this. Then the last thing is making a measure or add measure by clicking this pivot table field and add measure. Then you can start naming your first DAX calculation. Then you can now start calculate and everything. So that's it. Stay in touch, my friends. There will be a weekly update to cover all of these topics in next videos. This is to show how Microsoft Excel, Power BI, and Python can be used to automate data reporting, do query, and make analysis easier in real-world applications such as in supply chain, engineering, manufacturing, and financial industry. I will also do touch-up tutorial on few example of design of experiments or DOE using SASJOB and automate repetitive tasks in SolidWorks. So again, stay in touch. Thank you.